ranks of the world, the top sustainable city in the world, it's firstly is Oslo, and following with others city. If we look on the in Asia, first in the sustainable city is Tokyo, and then Indonesia and Malaysia also sit in as one of the top hundreds of sustainable city in the world and in the Asia as well. Okay, how about the bottom 10s? This is a bottom 10 of, we can see on the top of the right, but it's a top bottom of city in the world less sustainable. It's like first is Kinshasa, and then until Mumbai. Okay, and then what's the means of biological process? It's a lot of definition about the biological process. So biological process, I could simplify. Biological process is the process using a microorganism or organism, on any kind of organism like animal, plants, microbe, and so on, to create, to using as their reaction and so on to develop another product or another process. That is a definition stated in the slide about the biological process. What the difference between bioprocess and biotechnology? Biotechnology is a fundamental work, but bioprocess is like a processing to produce, to get something from organism. And then also the difference between biochemical and bioprocesses engineering. So the conclusion we can say, bio-related technology apply the production of process technique relating to products of agriculture, and the biological process tied to fuel and material production such as waste treatment, recycling, and hydroponic as well. So it's a lot of a definition of bioprocessing actually, but I try to simplify. And then the illustration shows the organisms, microorganism, and then bioreactor. That is, I could say this is a microorganism is a representative as organisms, and a bioreactor is organism. Bioreactor is a representative as is a tools. So that means it's a combination tools and microorganism to produce something. That is a I could conclude what is a biological process. Okay, the first technology I would like to present to all of you, I would like to share with you is about a probiotic chicken feed. So what's the problem motivate me to do this research? Okay, actually, if we look in the market, most of the chicken meat is contaminated with antibiotics. Okay. Okay. Most of meat in the market contaminated with antibiotic. This is because of chicken feed content of antibiotic. They put a lot of antibiotics, and then it's not good for human to continuously consume antibiotic because it will burden to our kidney. Then at the same time also food waste is a big issue and big problem in many countries, many cities in the world. Then what's the solution? So the solution, we using a food waste as a media to grow a probiotic for chicken feed, and then after that to give a feeding to chicken. So actually, the novelty of this research is using a microbes and process to convert food waste to become a probiotic and probiotic chicken feed and fulfill Malaysian standard MS20 2008 and international standard for chicken feed. So the applicability is a reduced environmental problem, and then reduce also about quality of chicken meats. So the intellectual properties is a copyright. It's already have a trade secret, and it also patented already. The commercialization is an ongoing commercialization with one of big company in Malaysia to produce probiotic chicken feed. So this is award we received from Croatia, actually. This is a chicken feed, probiotic chicken feed we produce. And then this is a laboratory scale, our bioreactor, our drying machine, and so on. And this is in the pilot scale, our pilot scale. And this is an industrial scale at the factory. We help the factory to develop the system and process for produce probiotic chicken feed. Okay, then the second technology we would like to share with all of you is about a leachate to ethanol and acetic acid and butyric acid. Okay, actually it have a leachate. Let me to explain what is a leachate. Leachate is a liquid. It's come from landfill. Normally it's come from landfill and then it's a pass through a solid waste, and it's a very hazardous and strong waste. I could say strong wastewater because it have a lot of heavy metal and so on. So we using that kind of leachate to produce ethanol and acetic acid and butyric acid as well. And then this project is a patented, granted already in Malaysia. And then now we are ongoing to commercialize with SW Corp, which is we can produce a bioethanol and acetic acid and butyric acid as well. Actually, for bioethanol, we using if we want to convert leachate to ethanol or bioethanol, we will use algae as a base to treatment leachate. Actually, it's not only produce a bioethanol, but it also treat leachate to become clear water and produce ethanol. But if we want to produce acetic and butyric acid, we will use a bacteria which is a Clostridium butyricum. Okay, this is a lab scale equipment, what we have done before this. So this is a main bioreactor, and then this is a raw leachate we can see here, and then this is a permeate. Permeate is a clean water, and then from the algae, this is algae, we can take a biomass from algae and produce bioethanol. Okay, this is a pilot plant. This is a raw leachate, treated leachate, and then this is a membrane, and then after that is a supernatant of permeate will go to the activated carbon, and then biomass we will go to fermentation to produce a bioethanol. Okay, this is a process flow for bioethanol. So we can see here the leachate with a high COD, high phosphorus, and high nitrogen. And finally, after we treat, we can reduce all of that. And then at the same time, we will produce a bioethanol. So it's like a kill two birds with one stone. And then this is a technique for produce acetic and butyric acid. Is from a bioreactor. We using a bacteria directly, using a bacteria, and then after that the bacteria Clostridium butyricum will produce acetic and butyric acid, and then we have a membrane filtration, and then this is our technique to split to purify acetic and butyric acid, which is using activated carbon, and then after that we can produce, we can get almost 90% of acetic acid and 89%. 70.8% of butyric acid. We can split all of them. That is our successful story. And now we are looking for, now we are ongoing to collaborate with industry to use in the industry. And then another thing is a leachate to wood preservative. Actually, it's a continuously from the second project, which is a leachate to acetic and butyric acid, which is the leachate produce acetic and butyric acid. Then we use the acetic and butyric acid to treat rubber wood, because we know the most of the preservative in the market for rubber wood is a very toxicity, and then it have a high content of heavy metals, and then it's it's not suitable for human health, because if you coating your furniture, sometimes you use it, you touch with your hand, so and then after that you touch your food, then so it's contaminated to your food as well. So we can replace a harmful preservative. So it's a patent filing as well and copyright. And this is the evidence, which is when we treat the rubber wood, we can see here, this is a rubber wood with treated with fermented or treated leachate, which is content is acetate and butyric acid. And then after that, we expose with a fungi. You can see here, white rot fungi is growth in the non-treated rubber wood, but treated rubber wood is free from fungi. Okay. Then now we go to the technology 4, which is a biocoating fertilizer. So a fertilizer is any material or substance which is we put in the soil to enhance fertility of soil. So however, 25% of fertilizer applied in the soil is not go to the plant, but is lost to environment due of rain, due of weather, and so on. So that is not good to environment actually, because it will create eutrophication. Eutrophication means it's a alga bloom in surface of our water surface. So it's not good to our environment, because when the alga bloom in our water surface, so that reduce the dissolved oxygen in our river. So most of biodiversity will die, and then it will disturb our biodiversity in the fresh water. So what we need to do is maybe we can, that's why we come with this technology, which is a biocoating fertilizer. Biocoating fertilizer is have a three function. First is the first is to slow release of a nutrient, and then second is a supply of microbes to soil, and then third is supply micronutrient as well. So the commercialization of this project is ongoing with FECRA, PISDA, and NAFAS. And then intellectual properties is just trade secrets. We're using three elements to coating the fertilizer. First is microbes. Second is cross-linking agent, and then matrix agent as well. Okay, this is a coating fertilizer. We can see here after coating a few months, actually almost a year, then the bacteria still grow there. The bacteria in the surface of fertilizer. If we using inorganic fertilizer, normally it will disturb, or it will make our soil become hard, because it's a content of high phosphorus. However, we can coat our inorganic fertilizer, so it's become a hybrid, which is an organic hybrid, which is because the coating is organic and the fertilizer inorganic, and it will save our soil become hard, because the bacteria will become a softener to our soil. So this is illustration, the picture from microscope, which is shows the coating, size of coating. We can design the size of coating as well. Okay, this is trials in the site, which is we can see here coated fertilizer and uncoated fertilizer. So you can see here clearly uncoated fertilizer after 2 months is gone with the environment. Okay, it's nothing left there, but coated fertilizer still have there. So it just slow release, and then release the sufficient nutrient to plant, and others is still remain there to become to a slow release. Now, and another things, technology 5 is about a self-healing concrete. Self-healing concrete is we induce the microbes into the concrete, and then it's if have a self-healing, it will if you have a crack, so it will self-healing by itself. Okay, but unfortunately at this moment it just can healing the micro cracks. only micro cracks. So for the big or the large scale, the large cracks is still, we are still working on that, but unfortunately we still not achieve the, we still not find how to to healing the major cracks by using this technology. Okay, this technology just we just copyright, and then we immobilize Bacillus sphaericus actually to POFA. POFA is palm oil fuel ash. After we burn in the furnace palm oil fuel ash, and then put in the, and then we immobilize it with Bacillus sphaericus, and then we mix with a concrete. Okay, the R&D actually is 100% completed, and then upscaling is just 50% completed. And then again, I would like to remind that the project is just can solve the problem for micro cracks only. Okay, this is what we have done in the lab. We try to create a quite big crack, but it's not sufficient. But when have a small or micro crack, so it grows very well. It's close the cracks very well. And then this is a process how to prepare the microbe, and then to induce with what's called with induce with concrete. It start from inoculum, and then vessel production, and then nutrient preparation, and then after that clarify, and then we get biomass of microbe, and then we mix with mortar generation, and then post treatment. And the last technology is about ammonia reduction in liquid and gas phases. Okay, as we know, this is my new invention. And it's still ongoing. Okay, as we know, in our environment, in our wastewater, in our air, is a lot of ammonia. Actually, ammonia is not good, even too high in our if we expose with a high content of ammonia. So we will try to solve this problem using a microbe. Actually, we using a microbe, and then actually we use a Bacillus subtilis to degrade the ammonia in the water and the liquid as in the water, wastewater, and the air as well. So the R&D is completed 80%, and this is the technique what we have done. This is a liquid phase. We investigate all of them in the laboratory scale only. Okay, so this is a grant what we have done. We get a grant 142 ringgit Malaysia, 79, and then we also receive a lot of awards. Actually, not just listed here, just 2 or 3 here, but actually we have received a lot more than that. And then this is our publication. You can see here our publication about technology 1, technology 2, technology 3, and so on. So the overall achievement, we graduated a lot of students, a lot of Ph.D. and RO as well. We published also 110 journal, 14 books, chapter, and 4 books related with this topic. Okay, and then we commercialize also this project to engagement with industry, patent, and so on. Okay, that's all from me. Thank you very much.
Okay, thank you for the knowledge you given today for our students. Now we move on the next section for question and answer. And again, thank you very much for Dr. Azam. So we have 5 minutes for question and answer. And for the audience, if you have any question, you can ask directly. You can turn on your microphone and or you can write the question in the chat box. Okay. You can raise your hand. If you have any questions, you can ask directly also. Okay. Anyone? Okay, Mr. Darmanto or Pak Darmanto, you can ask directly to Dr. Azam.
Okay, thank you very much, Pak Yasa. I want to ask about the parameter of healing of the concrete that you have done before in your research. What is the parameter of healing related with the mechanical properties, for example, of the crack? As we know that in the crack, there is a strength intensity factor in the tip of the crack that can make a crack propagate. So what is the parameter of the healing related with the properties of the crack itself? Thank you very much, Pak Yasa.
Okay. Please, Dr. Azam, you can answer directly.
Okay, thank you, Mr. Damato. Okay, that is a very good question. What's the parameter I measure during the test? Okay, before I answer the question, okay, let me to explain the process. The process is we cultivate the Bacillus paricus, and then so the parameter what we monitor and at the beginning is a biomass. So it's biomass and the consumption of carbon and so on. And then after that, we immobilize to determinous earths. And then after that, determinous earths and another mobile and another media like a POFA and so on. So after that, we measure how much the bacteria immobilized to POFA or determinous earths. And then after that, we harvest we take the determinous earth and a POFA, and then we mix with the concrete. Okay, and then after that, how we want to know the strength of the concrete is increased and everything. The POFA, we make another another blank profile, sample, control sample, which is not content of bacteria. So and then after that we test like compressive strength. We look on the honeycomb, and then we also look the using a UTM machine, strength, compressive, durability, water, and so on. So we check everything, and then after that we look also in using a SEM, spectrum electron microscope, to look the micro crack over there, and then compare with a blank sample. Then from that we can conclude which is that working or not. Is that clear?
Yeah, I think it's enough. Yeah, clear. Thank you very much, Pak Azam.
Okay, welcome.
Okay, thank you very much, Mr. Darmanto, for the good question. We have one question again. Okay. Anyone? Okay, we have one question from Jovanka Bernadette. You can ask directly, or you can write your question in chat box.
Thank you, sir. I want to ask a question. When bioethanol is produced, how to maintain the algae in order to in stationary phase?
Can you repeat again? How to maintain the?
How to maintain the algae? So, in order to in stationary phase.
Okay. Thank you very much, Jovanka. Okay. As I mentioned before this, the process to produce a bioethanol actually is not from algae. Actually, algae, we're using algae to treat a leachate. Okay, after that, after we treat a leachate, after we produce, after we remove a COD, heavy metal, and so on, we get a high content of biomass, from algae. Actually, the algae, then after that, algae go to the bioreactor for process of fermentation to produce a bioethanol. We're using a cychromasive to produce, to get a bioethanol. And then how to maintain stationary phase. Actually, the process to produce a bioethanol is a continuous process. So as we know, continuous process is stagnant process, which is a flow in and flow out. Okay, we maintain in the bioreactor. We have a system to control the parameter and everything. It's automatically. It's automatics. Sorry. Okay. Is that clear? I answer your question.
Yes, sir. Thank you.
Okay, welcome.
Okay. I think there are no questions. So if there are no questions, maybe we can stop this second section. So we want to appreciate you again for your explanation and your knowledge, your information, and your technology. And we sincerely hope that this partnership, collaboration can continue in the future. Thank you very much, Dr. Azam.
Thank you very much again to invite me.
Okay, thank you so much. Now we go to the last section, to the Assistant Professor Tetsuhito Suzuki. Is it here? Okay.
Yes.
Okay.
Can you hear me?
Okay. Please, Assistant Professor Dr. Tetsuhito Suzuki, you can start your presentation now.
Okay, thank you very much. So let me start my presentations. It is no problem for sharing the display. Okay. Hi. Hello, everyone, and thank you very much for introduction, and thank you very much for invitation. It is a very great honor for me to be here. So today, let me share our activities titled Light and Sound-Based Sensing Technology for Products of Agriculture, Livestock, and Aquacultures. Okay, I'm Tetsuhito Suzuki, Assistant Professor in Kyoto University. So firstly, let me introduce our overview of activity in our groups, especially for informatization of food products. And then I will focus one of the topics as examples. Okay, let me start from the first one. Then firstly, let me introduce our activity and about the laboratory at first. Our aim, our scope of the laboratory is basic and applied researches on a wide range of objects based on light and sound technologies. Then target material covers from for multi-scale target from molecule size level to facility size. For example, in the case of the molecules, water molecule dynamics can be discussed based on the terahertz spectroscopy, and by using the new sensors, we can constructing the cell and bacterial detection sensors, and tissues and products can be evaluated by spectroscopy and imagings. There are four staffs: Professor Kondo, Associate Professor Ogawa, and Assistant Professor for me and Shiraga, like this. Yes. Then this is a digest picture of our activities. For example, post-harvest non-destructive testing, informatization of food and agri-product, physical property of food, agri-product, bioinstrumentations, and this is terahertz technology is also mentioned here. So this is a relatively new technologies. Then we can developing the new sensor and spectroscopy, and especially for spectroscopy, we can discuss about water molecule, hydrated water and free waters around the proteins and others. Yeah, so this is also very interesting technology, basically. Then I prepared this picture. Then today, yeah, I was invited by Professor Dimas. Can you find him? Here. Yeah, I prepared this. This picture is taken 2019. So me and Professor Dimas is here. And I found other alumni, Muharu Fiza-san here. Yeah, maybe, yeah, he is here, I think. Okay, anyway, yeah, our laboratory's name is Biosystem Engineering Laboratory. So we are very welcome you. So if you have chance, yeah, why do we please come to our laboratory? Okay, let me start the brief introduction at first. This graph is the population in the world. Then a number of the population increasing and increasing. Now currently 7 billions, especially for Asia. Yeah, as you can see. Then in future 30 years, 2 more billion people appears. So it is very important issues that how to cover this food requirements. Then, yeah, there are 2 ways are suggested for our food production for 2 more billion people. One is to enhance productivity in open field with minimum environmental load. It is called that smart agriculture, automation, AI, and ICT. Then, this is the literature about the mechanization rate for rice production. I'm sorry, this literature is a little bit old, 2015. I'm sorry that. But anyway, in Japan and Korea, mechanization rate is fully mechanized. Then in the case of the China, so. Then in your country, Indonesia, very low. But I think, yeah, recently this one is much improved currently, I think. But anyway, amount of the yield is important because China, India, and your country, Indonesia, have much large yield. So such a mechanization and automation is very important story, I think. In the recently, Japanese agricultural machinery company, such as Kubota and Yammer, developed in the grading facilities, we can get the information of quality and defect like this. All information can be accumulated and input to database. Then, based on the result of the analysis, we can get some information and we can feedback to field for the next season. Such a IT-based smart management of the field and tree will be possible in the future, I think. So such a strategy will be important. And the core technique is sensing, we think. Actually, in our laboratory, we have several other researches. For example, foreign object detection by using millimeter wave. Yeah, actually, we constructed one big system with weld conveyors, and we can detect small rubber and glass and other material or foreign objects in partially. Yeah, it is possible to detect such small foreign objects. And we also constructed a new near field sensor for bacterial detection. So actual bacteria and dead bacteria can be distinguished by using such a very small sensors. And these are for safety and security. And the other for informatization, not only imaging and spectroscopy, other non-invasive diagnosis of the cattle is also researched. For example, pupil camera and behavior sensors. Such devices, such application can be used for making the high marbling meat. High marbling means high quality of the meat. Then actually fish volume estimation is also conducted by using sound resonance. But today, let me cut about the topics because of the limitation of the time. So today, yeah, in the time left, yeah, I will introduce the technologies for livestock, especially for the hatching eggs, diagnosis of hatching eggs. Okay, let me start from the introductions. This is a picture of the production of the meat and eggs. Then egg and the chicken have several advantages, such as a small feed requirement and short fattening period. So, and especially for your country, yeah, many Muslims cannot eat pork, and Indian people doesn't eat beef. So that is why chicken and egg become main protein resource food in the near future in the world. Yeah. But this field have several problems, especially in the hatchery farm. They face some problems, such as loss of gender, loss by gender, and hatching time. Actually, especially in the case of the layer chicken, male chick cannot produce the eggs. That is why more than 7 billion chicks are killed every year. Can you imagine these numbers? Actually, this number is almost the same to world populations. This is very, very terrible numbers. That's why killing male chick is beginning to be banned in Europe recently. And this will be an urgent issue in Japan and other countries. Then there are several existing techniques of the gender prediction. For example, chemical analysis. By making a hole by using laser, we can pick up this internal fluid, and putting the chemical marker, we can get the information of the gender, male or female, right, by color. Yes. And the other way is Raman and fluorescence spectroscopy. By making a large hole and irradiation of the laser like this, then it is said that male or female can be distinguished. But non-destructive methods are required without hole making, because such a hole enlarge the risk of the contamination. Hopefully, we should reduce, we should remove the making hole process. Then, this is the explanation of the hatching. So this arrow means the hatching time for 21 days. Then it is we think it is very important to construct a non-destructive measurement system, especially for early stage. So early stage of the early embryo forming. By detection of the gender, unnecessary, more than 50% of the eggs can be detected and sorted to other applications such as feed and vaccines. And hatching time, detection of the hatching time can enable us to control the hatching time to shipping days, so we can reduce the loss of hatching. So a reduction of the losses such as space, energy, financial costs, and life will be available in the future, we think. Next, let me introduce our activities first. In early stage of the embryo, we have research about the spectroscopies. It is possible to detect and distinguish the hatching time with ±3 hours in day 4, gender for 80% of the accuracy at day 3, and so on. Then in late stage, we can use the NIR, vital signs monitors. We can get such a graph. Cardiac means the heartbeat information and body movement information can be acquired by using these vital sign monitoring systems. In this stage, we can detect cardiac disease, delay of heart, and genders. Then next, let me introduce the very interesting topics. Yeah, as you know, determination of the gender is innate in the case of the mammal as our body, and was changeable in the case of fish and reptiles. And surprisingly, change of environment, such as temperature and social of condition, can convert the gender between male and females. This is very interesting. And then, in the case of the chicken birth, births are between them. And it is said that female conversion can be occurred by estrogen administration. But this one should be before day 6 in early stage. That is why early detection and sorting are very important, as I explained. Now we are trying to construct such a cumulative system of data acquisition, including the temperature measurement, vital sign measurement, transmission spectral measurement, imaging system, and the sound system. But there are many systems. So let me cut most of them, and let me focus only to spectrometer, spectroscopy, and imaging system. Okay. Okay. Then as a trial, we constructed such a system. White light from xenon lamp is irradiated from the bottom of the eggs and detected by spectrometers. And then the eggs are turned in horizontal directions. And by inserting a bandpass filter at 550 nanometer, we can get the imaging. We can get image by camera like this. This wavelength is determined based on the absorption of hemoglobin. Hemoglobin, that means blood. Blood has a very large absorption at about 550 nanometers. So we use this wavelength for the bandpass filter for making the good contrast. Then after incubation, about 21 days, finally we discriminated the gender by feather shape. Okay, these are the results of the images. As you can see, from day 0, day 1, day 3, gradually this black part enlarges. And from day 3, you can observe the vessel and embryo very clearly. This is because just after starting of the incubations, this yolk comes to enlarge and comes to upper like this. And blood vessel and embryo is formed on the surface. So that is why we can get such a clear change of the shadow like this. And by comparison, without and with filters, you can see that very high contrast in the case of the filters. So filter selection was very appropriate, we think. Next, these images are actual embryo and vessels after breaking the shell. Then, as you can see, embryo shape and vessel shape corresponded. And this shape also corresponds to the literature, biological literature. It says that a circular vessel is formed as a day 3 to day 4 and then disappears. This result corresponded to our images actually. So angiogenesis was clearly projected and time was consistent with the literature. Next, let me talk about the spectrum. Then this is a low spectrum of the transmitted light. Then at the about 550 nanometer, we can compare the absorptions between male and female. We can observe the significant differences between male and female only in day 3 to day 4, and then disappears. This is very interesting. We are not sure why, but yeah, hopefully we want to discuss based on our images and other data in the future. Then this day 3 to day 4 correspond to the beginning of the blood vessel formation like this, such circular vessels and embryo like here. So this stage is very important for gender detection, we think. So we hypothesize that embryo blood formation may be related to gender differences. So we converted the images to V-value and binarized to extract the area of the blood and embryos. But as a result, just the area has no clear differences between male and female. But we have tried deep learning for this raw images directly. Then we achieved 90% of the accuracy. This is very interesting. Actually, sorry, today I cannot show that result, but anyway, we achieved this result. So we believe, yeah, it has potential. So our next challenge is to consider image processing and indicators suitable for the gender estimations. Yeah. So in the future, today I talked about the diagnosis of the embryo forming by non-destructive method. Then actually in the future, yeah, based on this information, we want to try the active control of the embryo by stimulus such as heat and terahertz wave. Actually, terahertz wave is reported as the potential of the stimulus and active control of the cell activities. Yeah. So in future, yeah, we want to realize early sorting and innovative incubation for the futures. Okay, time is up. So let me conclude this presentation. So light-based new sensing technology was introduced. So yeah, it is very happy if you get good information from my presentation. Finally, I'd like to tell acknowledgement to many professors and professionals. Yeah, today I introduced the activity from our groups, but this is achieved by many professors and students and other companies. So I'd like to tell acknowledgement. Thank you very much.
Okay, thank you very much, Sensei. Maybe about your explanation to give us today, and we go to the next section for the question and answer. So we have 5 minutes for question and answer. And also for the audience, if you have any question, you can ask directly. You can turn on your camera and microphone, or you can write your question in the chat box. Okay. Anyone? Okay. So maybe I have a small question because it's very interesting knowledge, information that we can found, or we can identify the gender of the chicken before hatching. Is very interesting. So is it possible to apply this sensoring to the field of fishing, maybe in the reefing, in the large scale, to identify about where is the fish and so on, something like that? Is it possible to apply sensoring in the field of fishing?
Oh, sorry, applied to what? Sorry.
Apply this sensoring technology in the fishing industry, maybe in the fishing industry.
Fishing
industry.
Fish industry. That is also very interesting, I think, and a very important issue, I think. Then, yeah, of course, yeah. Actually, we have used the egg, but not only egg. Hopefully, we want to apply to many kinds of the animals, including the fish. And then, why advantage of the egg as a research material is to easy handling. Operation is very easy. We can touch directly because the egg is protected by rigid egg shells. But yeah, hopefully our objective is to monitor the embryo forming and growth. So this part is very common, not only for chick but other animals, I think. Then, so yeah, as I introduced, yeah, embryo forming is a little bit different between male and female in day 3 to day 4. This is a case only in the case of the chick, but other animals also, I think, that to distinguish male or female is important even for fish application. I have heard. So yeah, hopefully we want to do this one in other field, I think.
Okay. Anyone? The audience? Any questions? Or maybe you can raise your hand if you any questions. So for the maybe for the identification for the gender, so how many percentage the accurate of this technology? 100% or maybe less than 100 or?
Yeah, actually we have achieved 90% by using deep learning as a method. Then the company, actual how to say, egg sorting company, machinery company, yeah, accepted that percentage. Then of course 100% is difficult, but at least 90% is acceptable. Yeah, they said. Then actually, yes, of course, yeah, higher accuracy is of course desirable, but it is no need to sort completely at only one time. So gradually, with very high accuracy, we can reduce little by little. Such a way is one of the solutions for application, I think.
Okay. Maybe time is enough. Thank you very much for Dr. Tetsuhito Suzuki for your knowledge and for your information. And I regret to inform everyone that we have reached the conclusion of this webinar. And I would like to thank to our speaker once more for their informative and engaging presentation, as well as for the active participation of all attendants. If I made any error while moderating this seminar, I apologize. Thank you very much for Dr. Stefano, Dr. Husnul Azam, and also Dr. Tetsuhito Suzuki. Arigatou gozaimasu, Iroro arigatou gozaimashita. Thank you very much.
Thank you very much.
I close this webinar. Assalamualaikum warahmatullahi wabarakatuh. Good morning, and I return it to the MC, Mr. Ceremony.
Ladies and gentlemen, we finally come to the end of today's agenda. Again, I would like to say thank you very much to all of the speakers that have presented today, and I hope that everybody here today gained plenty from this webinar. Before closing this event, I would like to leave you all a quote by Robert Swan, an author who once said, "The greatest threat to our planet is the belief that someone else will save it." Let us all be guided by all the things that we have heard and learned throughout this webinar and be able to see and influence our futures. I would also like to apologize if I have made any mistakes, whether it be my words or action throughout this webinar. As your master of ceremony for today, I, Amira Nur Fadia, would like to say thank you very much for participating. Good morning and Assalamualaikum warahmatullahi wabarakatuh.